Alrighty, so year 10s, we're just running through everything that is on your checklist that's there on the side for your test. So, first 2 points, knowing where everything sits in an atom and knowing the charge of each subatomic particle. So we have protons, which are positive, that's the plus sign, neutrons, which have no charge, which is going to be a 0, and electrons, which are negatively charged. Collective shells for electrons are called the electron cloud. That's the first thing you need to know, where the parts are and what their charges are. Alright, next, you need to know periods are going down and groups are going across. Periods tell you the number of shells that an atom will have, and the group tells you what the properties of that element is. There's a periodic table at the back of your test. You should know what the period names are. You should know where elements belong on said period. Don't forget, you have the metal staircase that isn't drawn on your test on the periodic table, but it starts at above aluminium and it goes down across. Any element on either side of the staircase are called metalloids. I don't think you come across that terminology in your test, but just to make sure you know it, metalloids on either side on the metal staircase on a thing, on a periodic table. Okay. Next, atomic mass is equal to the number of protons and the number of neutrons. Add them together, you have your atomic mass. Okay, atomic number is the number of protons that an element may have. Okay, difference between metals and non-metals. You should be able to describe what the difference is. So, metal, what is it? Malleable and magnetic. Non-metal, they're typically brittle and non-magnetic. You should know on which side of the periodic table they are. If you get given a blank picture of the periodic table, you should be able to guess the properties of an element based on where it is. So say you have a table and you're given the element here is element P. You can look at this and go, element P looks like it's in column 6, in group 6, and then you should know what some elements are in group 6. If not, check the periodic table at the back of your test. There's also one on the side of the wall of the classroom for you to refer to as well. You can go, if it looks like it's here, it's going to have the properties of this group, and it's in period, and this example it's in period 3, so I know that it's going to have 3 electron shells, and it's probably, this isn't drawn properly, but from this to be in the 7th group, so it's going to be a halogen gas, and it's going to be very reactive based there. And then you could probably count the squares and tell me how many protons and electrons it has. Neutrons you wouldn't really know unless the mass is given to you. Alright, next. I know how to read atomic symbols. So that is the symbol here. You should be able to tell me what this element is. It's aluminium, or whatever it is on the inside. You should be able to read your periodic table and see. So say this was Hg. If you don't know what that is, you should be able to go through your periodic table and find Hg and be like, oh, I know that, that's mercury. That's what that means. Should be able to read it and know what that is. I know how to read and write electron configurations. So you should be able to, this is hydrogen, you should be able to draw 1 shell, 1 electron. That's for hydrogen. Regardless of what it is, helium, 2 electrons. Don't forget, atoms like to be neutrally charged, so the number of protons and the number of electrons are going to be the same. So if you know that element, what number the element is, you need to make sure it has that many electrons on it. You only know for the first 20, so what's 20? Calcium? We have 1, 2, 3, 4. So 2, 8, 8, and 2. Okay, 8 and 8 is 16, 2, 18, 20. Right? That's it. That's the biggest one you're going to have to draw. You should be able to draw that diagram with the correct number of rings. I don't want to see another ring around calcium like that. Because what that's saying is that there is an electron shell here that is empty, which is incorrect. Calcium only has 4 shells. I should only see 4 circles around it, no more. I can tell what type of ion an element will be based on where it is in the periodic table. So, metals, normally positive ion. Non-metal, negative ions. Okay? So when you have ionic bonds like NaCl, which are formed between a metal and a non-metal, okay, your metal is going to be positively charged, your non-metal is going to be negatively charged. Okay, looking at the periodic table, you should know that. Okay, so a very poorly drawn metal staircase. All of these things here, negative charge. Everything else in here, positively charged. Okay. Know how to use a valency table. We're given one. It basically tells you if something is like Ca might be 2 plus, it means it can give away 2 electrons, or if it's Cl and it's -1, it will gain 1 electron. Okay, that's what those numbers mean. That's what you need to be able to tell me with the valency table. You should be able to read it and see, I can see that copper has a 2 plus or a 3 plus, depending on the type of copper that it is. So that means it can either gain 2 or it can lose 2 or 3 electrons. That's what being able to read a valency table looks like. I know how to name elements based off a valency table. So if you have a valency table and you have, going back to copper, Cu3 plus, that is copper 3, because it has 3 plus on it. If there was a 2, it would be copper 2. Okay, that's how that works. Alright, I know how to write chemical formula. You should be able to write any chemical formula that's given to you. They're not going to be anything that you haven't seen before. So you should be able to write something like water, or salt, or hydrogen peroxide, things like that. You'll probably be given the name. You'll be given the name of the chemical compound. You should be able to tell what it is that it's asking for. So say you have magnesium sulfide, you know you're going to need a magnesium and you're going to need a sulfur, and then whatever you need to put to make it the iode. You will have a solubility table as well on that. Okay. I know how to use valency tables and a periodic table to determine the chemical formula of a compound. So if we go to water, H2O. If you look at a periodic table of the elements, you know that water is, oxygen is here, and it wants 2 electrons. O has a valency of -2. So it wants to be balanced, so it's going to take 2 hydrogen, because hydrogen will release 1 electron, and oxygen wants 2, so it takes 2 of them. So you should be able to read a valency table and be like, yes, I see this element here, chlorine, wants 1 electron. So it can bond with anything, that will give it 1 electron. Then we have HCl, which is hydrochloric acid. Okay? Should be able to read a table and be like, this wants this many, this can give this many, if I put them together, I'm going to get up with this. And you need to make sure that it evens out. Like with water, oxygen wants 2, hydrogen only has 1 to give, so it needs 2 hydrogen for 1 oxygen. Okay. Another difference between ionic and covalent bond, and I can explain the difference. Ionic bonds between a non-metal and a metal, covalent bonds between two non-metals. Oops. Metal and metal. Okay, so covalent bond, non-metal and non-metal, ionic bond, metal and non-metal. Okay, bond together, they want to be even, they want to be balanced. This here is, that becomes positive, that becomes negative. These two here, they share electrons. Okay, they share electrons to be balanced. This, the metal will actually give up an electron, which bonds it to the non-metal, which becomes negative, because this is given up one, it's positive. This is now negative. They bond together and they stay together. These ones here, they share together. Okay. I know what a precipitation reaction is. All right, a precipitation reaction is when you mix two liquids and you get a solid. Mixing two liquids to get a solid. Now normally when you get this in a formula, down the bottom it will have something little and there'll be an AQ. That means aqueous, which dissolves, means it's dissolvable in water. If it has a little S, it's a solid. Has an L, it's a liquid. And has a G, it's a gas. These should be in your chemical formulas when that are given to you. And that should inform you as to what becomes what. Okay. Ready? Next, I know how to read a solubility table and how to use it. Solubility table tells you how soluble a compound is or isn't. You should be able to read and identify the parts of a solubility table, what is on there and how they break down. It's literally given to you on the table. You can look at it and go, phosphates. Phosphates are not very soluble, therefore they're not going to dissolve in liquid. That is an example. I don't have one on me. I don't know if that's correct or not, but that's basically how you read one. Okay. I can figure out what the products of a reaction are and I can write the product out as a chemical formula. This is going to, what was it? It was hydrochloric acid plus a metal, I think it was calcium. And what does that go to? What does that go to? So what's going to happen is hydrogen wants to be by itself as a gas because that's when it's most stable. So the chlorine is going to jump and bond to the calcium. So we're going to have calcium chloride. Whenever you're naming ionic bonds, metal goes first, non-metal comes second. So we have calcium chloride plus hydrogen gas. That's H2. Now, this is unbalanced because we have two hydrogen here and only one hydrogen here. When it comes to balancing equations, draw up a table underneath the equation. Write out what each element is that you have available. Okay. Now granted, it would be better if you wrote the elements in line, but for efficiency's sake, we are not doing that. Okay, so on this side, hydrogen, I have 1. Chlorine, I have 1. Calcium, I have 1. Calcium on this side, 1. Chlorine, 1. Hydrogen, 2. Now we need to make this balance. Hydrogen 2 on this side, I want 2 hydrogen on this side. So if I stick in the front here, a 2 at the front. Hydrogen now has 2, Chlorine now has 2. Okay? When it comes to actually doing this in a test, don't erase that. Just cross it out instead. So I will do that here. Okay. So originally we had 1 and 1. Now, actually going to do this in different color. Alright, so we've added the 2 at the front. So we're crossing that out. Cross it out on a diagonal so your original number can still be seen underneath it. This means if you've made a mistake with your final answer and we've seen that you've gotten the actual answer, we could probably still give you marks for doing the working out correctly. So now we have 2 hydrogen and 2 chlorine. Okay, great. However, back on this side here, we only have 1 chlorine. We want 2 now. Cross this out, make it a 2, stick a 2 at the front there. So stick a 2 at the front. Now we have 2 chlorine, but we also have 2 calcium. Okay, so that means 2, 2. This one here is unbalanced. How do we get 2 of these? Stick a 2 at the front, and now we have 2. And now this entire thing is balanced. That is how you balance reactions. Always draw a table. Always write down products versus reactants versus products. So you can see everything on a table at the end. You can see all of these are now balanced. It's one happy equation. It's all there. Alright. Next. I know how to draw electron dot diagrams. Alright, electron dot diagrams are a pain in the butt to do, but we're going to do them anyway. Alright, so we're going to be using water as an example because it is the easiest. We have oxygen, hydrogen, hydrogen. You should all know how to draw this. Now, we know that oxygen has 2 valence, 2 electrons in its outer shell. Hydrogen has 1. Now, oxygen's 2 are down here because they're not attached to anything, and hydrogens are up here, and they want to because oxygen wants them, it takes them. So that's basically saying that's where the bond is. That's what they're sharing. So that is one way to draw an electron dot diagram. You could also have oxygen draw its ring, draw its valence electron shell, hydrogen draw its valence electron shell, and draw them so that the shells are touching. Okay, and then this here, they're sharing an electron, they're sharing an electron, and the 2 spare ones are there. Okay, I don't really mind which way you choose to do your electron dot diagram, as long as I can see that you have the different types of atoms, the correct amount of them, and where they're sharing electrons. So whether that be this here, hydrogen, hydrogen, oxygen, they're bonded with that one, they're bonded with that one, and these are your 2 spare ones. Or you go all out and you stick the rings on there as well. I don't mind as long as it's legible and I can see electron, electron, atoms, valence electrons, happy compound. Okay? And you can read electron dot diagrams. So you should be able to look at this and go, oh yeah, I can see that's a hydrogen. There are 2 hydrogens, there's an oxygen. Hydrogens are sharing oxygen, electrons with oxygen, 1 each, and oxygen has 2 spare electrons. You should be able to read that and be like, I know what this means. Okay? Alright. Now there was a couple of questions which we're going to quickly go through. Alright, first question. How to find the subscript of an element? Alright, if you write a chemical compound or any sort of writing, this number down the bottom here, this is subscript. Okay, so subscript means it's just down the bottom. If you're referring to the number of elements in a molecule, you write it down the bottom here. If you are referring to the charge, you write it up the top. I do not want to see charges down the bottom and numbers of elements up the top. Number of element down the bottom, subscript. Charge up the top, this is called superscript. Okay? That's what I want to see. Okay, we've gone through how to balance a chemical equation. Make sure you have that table there. Make sure, write out all your working out. Strike a single line through your work if you're not happy with it. Do not erase it and do not rub it out vigorously so it can't be seen. Okay, crash course of covalent bonding and ionic bonding. What's the difference and maybe examples? We've been through that a bit, but just a refresher: ionic bonding, non-metal and a metal. Covalent bonding, two non-metals. Ionic bonding, the metal gives up an electron to become positive. The non-metal gains the electron, becomes negative. The opposite charges make them stick together. With covalent bonding, you have the two non-metals that share electrons, so they're both happy. Okay, that's the difference between the two. So if you're unsure if something is covalently bonded or ionic bonded, look on your periodic table and find where your elements are. You should be able to spot the difference between a non-metal and a metal on your periodic table. I have full faith that you can do that. You're all smart and you know more than you think you do. Alright, about insoluble. So if something is insoluble, it means it does not dissolve. Specifically in chemistry, we talk about dissolving in water. So if you read the solubility table, it should tell you what is or isn't insoluble, or if it's partially insoluble, which means it'll dissolve a little bit but not a lot. So you need to go through and you need to be able to identify that on a table. Okay, electron dot diagram we have just done. Do not forget also about rates of reaction. So rates of reaction talk about how fast the reaction goes. It's either referring to speeding up a reaction or slowing a reaction. There's 5 different methods of speeding up a reaction. You only need to concentrate on 4. We tend not to talk about agitation because that's something done at a higher level, but you need to worry about temperature, temperature, surface area, a catalyst, and concentration. There's the 4 you need to worry about. So increasing all of those things will make the reaction go faster. Decreasing them will make it go slower. Catalysts are the odd exception to that because they are something you add to a chemical mix that doesn't get used up in the reaction, but it makes the reaction go faster. It lowers what's called the activation energy of the mix. All right, I believe that is it. You'll be fine. You guys know more than you think you do. You're very smart little cookies. All right, good luck with your studying, and I hope you enjoy it. I'm sure you won't, but try, and good luck with your test. Bye.